Let us discuss question number 13 and 14 of Code 9 of Subject Physics of JEE Advanced 2015 Paper 1. In question 13, we are given with two independent harmonic oscillators which are having equal masses, and then we are given the variation of their momentum with respect to their displacement from the mean position. Okay, so what I want, let us first recall what are the standard equations for the SHM. As we know, the displacement for SHM is given as A sine omega t. I am taking here the initial phase as 0, okay, and then you can write V is equal to A omega cos omega t, okay. And then the last equation which we will need to solve this problem will be value of energy, which we know is equal to half m v square, and if I take the total energy of the system, it will be equal to half m a square omega square. Okay. So now let's first take let's let's consider this is case 1 and this is case 2. So first consider the case 1. In this we know that the amplitude of the displacement amplitude of x is equal to a, and from the equation which we have written earlier we know that amplitude is equal to a. So here we can say that amplitude a1, the displacement amplitude for case 1 is equal to a. Okay, and from this equation we know that a is equal to nr. Okay, so now then we know that our v is given as a omega cos omega t, or if I say that what is the amplitude of v, then we know the amplitude of v is a omega. So if I talk about the amplitude of the momentum, it will be equal to it will be equal to mass into maximum value of velocity, which is a omega. So I can say P max is equal to mass into a1 omega 1, a1 omega 1, and if I put this omega value of a1 as nr, I will have n m n r into omega 1. But from the curve which is given to us, we know that maximum value of P is actually equal to B. And from this relation, we know that B is actually nothing but R divided by N. And from this, we can calculate the value of omega 1. And if I take all these terms on the other side, this R will cancel out and I will get 1 divided by n square m. Okay, so let's say this is our first equation where we have calculated the value of omega 1. Okay, so now let's take the energy of this first case. This is equal to half m into a square. The a is the amplitude of the displacement, which we know is equal to nr. So half m into n square r square into omega 1 square, and omega 1 we have already calculated, so it is equal, this will be divided by n square m whole square. Okay, so if I simplify the equation, I will be getting half r square divided by n square m. Okay, so let's say this is my equation 2 and I have here calculated the value of E1. So now let's take the case 2. In case 2, we are given with a circle, so we know that the maximum amplitude of P and maximum amplitude of X both are same. So I can say that my A2 is actually equal to R, and if I take my P max, then P max is actually mass into velocity amplitude, that is m into a2, which is r, into omega 2. And from the graph we know that this is equal to r, so r will cancel out from the both side and we will be getting omega 2 as 1 divided by m. So let's say this is our equation number 3. Okay, so now if I calculate the energy for the second case E2, this will be equal to half m into a square, and our a in this case is r, so it will be half m r, and then omega 2 square, so it will be divided by m square. So we will be getting half r square divided by m. Okay, so this is our equation 4. So now we have calculated the values for omega 1, E1, omega 2 and E2, and using these values we can verify the relations which are given to us. So if I see that E1 into omega 1 and on the other side we have E2 into omega 2, this equation will not hold good, because in on E1 and omega 1 we have the terms of n square in the denominator, but we don't have it on the right hand side. So this equation will not hold good, and let's try this equation number 2. So omega 2 divided by omega 1, this will be equal to 1 divided by m divided by 1 divided by n square m. So m will get cancel out and we will be left with n square, which is actually our equation number B. So option B is correct. Option B is correct. Okay. So now try equation C. We have already seen that omega 2 divided by omega 1 is equal to n square. So C cannot be true. Okay. So now let's try equation D, where we have to find E1 divided by omega 1. So our E1 divided by omega 1 is actually 1 divided by n square m divided by half of r square divided by n square m. So let's cancel this n square from the both side. We will be getting 1 by m divided by half of r square divided by m, and this 1 by m is actually omega 2, and the term in the denominator represents E2. So as we can see that expression D also holds good. So our option D is also correct. So our answer will be B and D. Okay. So now move to the next question. This question actually what it says that there is a ring of mass m which is rotating about the origin, and there are two small masses which are also in the motion. So initially these two small masses are at their center, but once the angular speed decreases, these masses moves outward because of conservation of angular momentum. So let's apply the angular momentum conservation and equate the initial angular momentum with the final angular momentum. So in the initial case, the angular momentum due to the ring will be equal to, let's say it is equal to I into omega plus the momentum due to the smaller masses will be 0 because they are at center in the initial case, so that will be 0 plus 0. Okay, and this I, we know that for ring it is actually m r square. Okay, so our initial linear angular momentum becomes m r square into omega. So now let's see what will be the final angular momentum. We can take the angular velocity, which is same for all the masses outside, and then we have this ring which is actually having the moment of inertia mr square, plus we have one small mass bead which is at a distance of 3 by 5 r. So for it we will have the mass m, and the radius is equal to 3 by 5 r. So it is 3 by 5 square into r square, plus let's say the second bead is at a distance of small r from the center. So in this it will have m and small r square. So these two are actually masses of the small beads which are given to us as m by 8. Okay. So in this case what we can do, we can cancel omega from both sides. Okay, and we can cancel this capital M from all the terms because it is common, and let's take this 9 on this side and multiply 8 inside. So we will be left with 9r square is equal to, when I take this 8 inside, I will be having 8r square plus this 8 will get cancelled out, this 8 will also get cancelled out. So I will be left with 9 divided by 25 r square plus small r square. Okay, so if I take this 8 r square on this side, I will be having this 1 r square, and if I take this 9 by 25 on the other side, I will be left with r square is equal to 1 minus 9 divided by 25 into capital R square, which is actually 16 divided by 25 r square, and if I take square root on the both sides, I will have my small r as 4 divided by 5 capital R, and this will be my answer to the problem, which is actually our option number D.